Welcome everyone. Through this video, I'll discuss today some interesting problem of functions. Today I will discuss problems involving functional relation. Before we start, we discuss some functional equations satisfied by some typical functions. These are well-known results. So number 1. If x plus y, fx into fy, then fx equals to a to the power x. Fx equals to a to the power x. Very simple proof. Look, fx plus y. What is fx plus y? These are obvious relation, a to the power x plus y. So rule of indices, a to the power x into a to the power y. This is fx and this is fy. Now second one. So if xy product, then f xy equals to fx plus fy. F xy equals to fx plus fy. Then fx equals to log x. So this is well-known result of log x plus log y. Log of xy. Log of xy means fxy. Similarly, if we use division of log, if x by y, fx minus fy, then it is also log x. Fx plus fy, fx into root over 1 minus y square plus y into root over 1 minus x square. So fx equals to sine inverse x. Because sine inverse x plus sine inverse y, you know, sine inverse x into root over 1 minus y square plus y into root over 1 minus x square. So this is true for minus also. Then 4, fx plus minus fy equals to fxy minus plus root over 1 minus x square into root over 1 minus y square. So here fx is cos inverse x. You may put fx equals to cos inverse x, then you may verify the result. Then problem number 5. Tan inverse x plus tan inverse y. Tan inverse x plus y by 1 minus xy. So fx plus fy, f of x plus y by 1 minus xy, then fx equals to tan inverse x. If we take minus, then it is minus, it is plus. So these three using inverse circular functions. Now 8, this is most important result, fx into fy equals to fx plus f1 by fx into f1 by x equals to fx plus f1 by x. Here it is product, here it is sum. Then fx equals to 1 plus minus x to the power n. Problem number 7. Odd function has symmetry of graph about origin. Symmetry of graph about origin. That is, what is odd function? Fx equals to minus f of minus x. So if a function has symmetry about origin, then it is odd function. Even function has symmetry about y-axis. That is, if we replace x by minus x, function is not changed. It is symmetry about y-axis. So that is fx equals to f of minus x. 9. Symmetry of graph about a0. F of a minus x equals to minus f a plus x. Look, if a equals to 0, then it is symmetry about 0, 0. Look, f of minus x minus fx. It is odd function. And finally, symmetry of graph about x equals to a. F of a minus x equals to f of a plus x. So we use these results for solving problem involving functional relations. So these are our basic concepts. Now I consider two most interesting problem. So look, problem number 1. If fx be a polynomial function satisfying fx into f1 by x equals to fx plus f1 by x and f3 equals to 28, then find f4. So we have already discussed, if a function, polynomial function, satisfies the relation like this, fx into f1 by x equals to fx plus f1 by x, then fx is 1 plus minus x to the power n. So we can write fx equals to this one. So one additional condition is given, f3 equals to 28 implies 28 equals to 1 plus minus 3 to the power n. So this implies 3 to the power n equals to 27, taking positive. So n equals to 3. So if you take negative minus 3 to the power n equals to 28. So not possible. So we are getting n equals to 3. So if n equals to 3, so what is our function? So 1 plus 3 to the power 1 plus x to the power 3. X unchanged, so n is 3. Now we have to calculate f4. So what is f4? 1 plus 4 cube, that is 65. 64 plus 1. So what is f4? f4 equals to 65. So B is correct option. So listen again. Fx f1 by x, fx plus f1 by x. So fx is polynomial, so fx is of the form. So you take positive to get n. N is integer. Now problem number 11. So fx be a polynomial function satisfying fx plus fy plus fxy equals to 2 plus fx into fy. xy belongs to R. So look, our main aim will be to get a relation of this type. So if we put x equals to 1 by y, that is xy equals to 1, then what we are getting? Fx f1 by y plus f1, 2 plus fx into f1 by x. So we get the previous relation. So fx plus f1 by x equals to fx into f1 by x. If we can prove f1 equals to 2. So suppose this is relation 1 and given relation is 1 and this is 2. So our main aim will be to find f1. So to get f1, we put x equals to 1, y equals to 1 in 1. So f1 plus f1 plus f1 equals to 2 plus f1 whole square. So 3 f1, this is f1 whole square minus 3f1 plus 2 equals to 0. So f1 minus 2 into f1 minus 1 equals to 0. So we are getting f1 equals to 2 or f1 equals to 1. So f1 equals to 1. So here it is given f1 not equals to 1. So f1 not equals to 1. One additional condition. So if f1 not equals to 1, so what we are getting? f1 equals to 2. So finally we are getting f1 equals to 2. Now we put this value of f1 in equation 2. So if we put fx unchanged, f of 1 by x unchanged, f1 equals to 2, fx into f1 by x. So 2 cancel. So we are getting previous relation. So we are getting fx equals to 1 plus minus x to the power n. Now it is given f2 equals to 5. So f2 equals to 5 implies, so 5 equals to, if we take positive sign, so x to the power 2. So x square equals to 4. So x equals to 2. X equals to 2. 1 plus x to the power n. So, x to the power n. X to the power n equals to 4. So, what is n? n equals to 2. 1 plus x to the power n. X to the power n equals to 4. X to the power n equals to, so f2 equals to 5. So, 5 equals to 1 plus 2 to the power n. So 2 to the power n equals to 4 equals to 2 square. So n equals to 2. Listen again. f2 equals to 5 implies 5 equals to 1 plus 2 to the power n. 2 to the power n is 4, n equals to 2. We take here plus. In general, it is plus minus 1. So if we take negative, we are not getting n as integer. So n must be integer to be fx, a polynomial function. So what we are getting? So n equals to 2. So form of fx is 1 plus x square. So what is f2? f2 equals to 1 plus 2 square equals to 5. So it is also given f2 is 5. f of f2. So f of 5. So 1 plus 5 square. So this is 26. So what is f of f2? f of f2 is 26. This is most interesting problem. You look, fx plus fy equals to this. So this relation is not given using x equals to 1 by y and putting x sum 1, y sum 1, it can be reduced to the relation number fx into f1 by x equals to fx plus 1 by x. So this is most interesting problem. Now we consider 2 more interesting problems. So problem number 9 first. Which of the following functions have graphs symmetrical about origin? Symmetrical about origin. Fx plus fy equals to fx plus y by 1 minus xy. So look, we have already discussed fx plus fy equals to fx plus y by 1 minus xy. So this is for tan inverse x. Try to recall. If fx equals to tan inverse x, then it satisfies functional relation like this. Now, you know it is tan inverse minus x minus tan inverse x. So, f of x with negative. So, this is odd function. That is, it is symmetric about origin. So, first one is symmetric about origin. Is multi-option correct problem. Now, B. So, this relation is satisfied by sine inverse x. Sine inverse x. So, fx equals to sine inverse x, then this relation is satisfied. And in this case also, f of minus x, sine inverse minus x. So, minus sine inverse x minus fx. So, it is odd function. So, it is also symmetric about origin. Now, third one, fx plus y equals to fx plus fy. So, look, fx plus y, we have already discussed this problem. So, if we put y equals to minus x, then 0 equals to f0 equals to fx plus f of minus x. If we put y equals to minus x. Now, if we put x equals to 0 and y equals to 0 to the given relation, so we get f0 equals to f0 plus f0. This implies f0 equals to 0. So, if f0 equals to 0, what we are getting? Fx plus f of minus x. That is, f of minus x equals to minus fx. Again, it is odd function. Therefore, it is symmetrical about origin. So, A, B, C, multi-option correct. So, it is problem of Wbjee or for IIT also. So, this is problem number 9. So, you have to recognize the function if functional relation is given. Now, problem number 8. So, this is very simple problem. Try to recall fxy equals to fx minus fy. So, it is satisfied by fx equals to log x. It is satisfied also fx equals to a to the power x. So, let us verify what is f x by y. So, f x by y. No, this is fx by y. So, it is satisfied by fx equals to log x. Now, look, if fx equals to log x, we know it is defined for, it is continuous for x greater than 0. Domain is 0 to infinity. So, look, f1 by x. What is f1 by x? Log 1. f1 by x equals to log 1 by x. So, minus log x. So, not tends to 0 as x tends to 0. So, this is not possible. It is also not bounded. x into fx is x into log x not 1. So only option is fx equals to log x. So bounded means its value lies between two definite number. So this is very simple problem. Now we consider one more problem using functional relation. So typical function fx plus y plus fx minus y equals to 2fx fy. So fx plus y plus this. Suppose fx equals to, it is not discussed, so fx equals to cos x. So what is fx plus y? So cos x plus y. And what is fx minus y? This is cos x minus y. So if we take fx plus y plus f of x minus y, so cos x plus y plus cos x minus y equals to 2 cos x cos y. You know, this is 2 into fx into fy. So look, this result, if f satisfies this result, then what is fx? Fx is cos x. So fx is here cos x. So if fx is cos function, then you know fx is even function. So odd function, it is not correct. So f of 2, what is f of 2 equals to f of minus 2. This is also true for even function. But this one is not true. This is minus b. So this one is not true. So option number A and C is correct option. So if this relation is given, so this typical relation, then function will be fx equals to log x. So these are most interesting problems. Now we consider two more problems. They are of same type. Look, f2x plus y by 8, f2x minus y by 8 equals to xy. Then what is value of fn comma n plus fm comma n? This relation equals to 0. Then what is a restriction on m and n? This is our problem. So look, so our main aim will be to express it as a function of x comma y. So this as single variable, this as single variable. So let 2x plus y by 8 equals to p and 2x minus y by 8 equals to q. So if we add, so 4x equals to p plus q. So x equals to p plus q by 4. Now if we subtract, so 2y by 8, 2y by 8, subtract 2y by 8 equals to p minus q. So what is y? So 4 into p minus q. So this is our value of x and y. So f of this is p and this is q equals to what is x? P plus q by 4 and this is, so p minus q. So p square minus q square. F of pq equals to this one, p square minus q square. So this is our main aim, single variable, single variable. Now what is f of q comma p equals to q square minus p square. So first one whole square minus second one whole square. So this is q square minus p square. So if you add them, so f of p comma q plus f of q comma, so we get 0. So this is 0. So we are getting this relation. So whatever may be the value of p and q. So there is no restriction on p and q. So it is only for m equals to n, not equals to m equals to minus n, for all values of m and n. Option D is correct option. So second one is exactly same. You consider this as p and this as q and find x. Find x. So you try it. Now we consider 3 more problems. So problem number 3. fx plus 1 plus fx minus 1 equals to 2fx and f0 is given. Find fx. So f0 is 0. So we know to solve this type of problem, we have to put suitable values of x. So first we put x equals to 0. Putting x equals to 0 to the given relation. So this is f1, this is f0, this is 2f1. So f0 is, this is f1, this is f1, this is f1. So this is f of minus 1, so it will be negative. So put x equals to 1 first. So this is f2, f2, so this will be f0, 1 minus 1, this is f1. Now f0 is 0, so what we are getting, f2 equals to 2 into f1. So this is f2, 2 into f1. Now if we put x equals to 2, so what we are getting, f3 plus f2 plus x equals to 3 equals to 2. If we put x equals to 2, this is f3, this is 2 minus 1, this is f1 and this is 2f1. So what is f3? 2f1 plus f1. So 3f1. 3f1. So putting x equals to 3, so f4 plus f2, f4 plus f2, 2f3. So f4 equals to 2f3 minus f2. So what is f3? 3f3. So so f3 is 3f3 and putting x equals to 3, this is f4 and this is f2 and this is 2f3. So what is f4? 2f3 minus f2. So what is f3? So 6f1 and what is f2? 2f1. So this is 4f1. So if it is f4, 4f1. If it is f3, 3f1. If it is f2, 2f1. So by induction method, what is fn? N into f1. So fn is n into f1. So for this type of problem, we put suitable values of x to get our desired result. Now, problem number 4. Problem number 4. So relation is fx plus half plus fx minus half equals to fx. So we have to find period of fx. So replace x by, if we replace x by x plus half, so this will be integer. So this is fx plus 1. So this is fx plus half minus this f of x plus half. So this is 1, this is 2. So if we add 1 and 2, what we are getting? 1 plus 2 implies fx plus half, fx minus half, plus fx plus 1 plus fx. So this is fx plus half. This plus this plus this. So fx cancel. Fx plus half is, fx plus half also cancel out. So finally what we are getting? So we are getting fx plus 1, fx plus 1 equals to minus fx minus half, minus fx minus half. So to get fx, we have to replace x by x plus half. So replacing again x by x plus half, we get fx plus half plus half. So x plus 1 plus half, f3 by 2 equals to minus fx. Minus fx. So fx plus 3 by 2. So fx, you have to find period of fx. So now replacing to get it integer x by x plus 3 by 2. So we are getting fx plus 3 minus fx plus 3 by 2. Now what is fx plus 3 by 2 minus fx? So this minus plus. So finally we are getting fx plus 3 equals to fx. Fx plus 3 equals to fx. So what is the period? Here also we are getting fx plus 3 by 2 minus, but this is period is f lambda plus x equals to fx. Then lambda is called period. Lambda is integer. Now look, here lambda is integer and this one is plus. So what is period? Period equals to 3. So what is the period? Period of fx is 3. Now last problem, exactly same type of problem. So f3x plus 2, f3x plus 2. Now we want to get this relation. We replace x so that we are getting this one. So if we put x by x plus 9, so 3x plus 27 plus 2, x plus 29. So replacing x by x plus 9, so this is our relation number 1. So what we are getting? 3x plus 27 plus f, 3x plus 27 plus 2, 29. F, what is 3x? So 3x plus 27 plus 29. So this is 56. 3x plus 56 equals to 0. So this is equation number 2. So if we add these two relations, so if we add, so look, this one, if we subtract, so f 3x plus 2 minus f 3x plus 56 equals to 0. So this one cancel out. Now what we are getting? F 3x plus 56 equals to f 3x plus 2. So we can write it as f 3x plus 2 plus 54 equals to f 3x plus 2. So period of, if we consider this as z, period of, so that is period of fz equals to 54 equals to f of 3x plus 2. So period of f 3x plus 2 is 54. So this is A is 3. So what is period of fx? Period of fx is 54 by 3. This is 18. 54 by 3. We are getting period as 18. So 18 will be period. So listen again. This one is given relation. Our main aim is to get this one. So x is replaced by x plus 9. So cancelling out. So this is 3x plus 2 plus 54. If we take 3x plus 2 as z, so fz equals to fz plus 54. So period of f 3x plus 2 is 54. So what is period of fx? 54 by 3. That is 18. So this is also most interesting problem. So today through this video we have solved some interesting problem of functional relation. You solve rest of the problem from description box. Thank you for today.